Diorite and granite are two igneous rocks that often get confused with each other. This is because they can appear very similar in color and texture. And for most people, without prior knowledge, it would be nearly impossible to tell them apart. But did you know that these two rocks have very different mineral compositions? So different, in fact, that scientists use them to help determine if the Earth's interior has been turned inside out, kind of like an Oreo cookie. In today's episode, we are going to look into the properties, uses, and differences between diorite and granite. Diorite vs. Granite. Unlocking the secrets of Earth's hidden gems, diorite and granite are both igneous rocks, which means they are formed from the cooling and solidification of magma or lava. However, they differ significantly in their mineral composition and texture due to variations in their formation process. Diorite is a medium-grained, intrusive igneous rock. Intrusive igneous rocks are those that form when magma cools slowly beneath the Earth's surface, allowing for the formation of relatively large mineral grains. The main mineral in diorite is hornblende, a dark green to black color silicate mineral. Other common minerals include plagioclase feldspar, which can exhibit a range of colors from white to greenish gray, and biotite, a black mica mineral. The presence of these dark minerals gives diorite its characteristic dark gray or black appearance. The texture of diorite is typically fine to medium-grained, meaning that the individual mineral grains are relatively small, but still visible to the naked eye. Some diorite varieties may also exhibit a porphyritic texture, which means they contain large crystals embedded in a finer-grained matrix. On the other hand, granite is a coarse-grained intrusive igneous rock. Like diorite, it also forms from the slow cooling of magma, but it has a higher silica content. This results in a lighter-colored rock with large visible crystals of minerals such as quartz, feldspar, and mica. Granite typically has a distinctive light gray or even pinkish color, due to the presence of quartz and alkali feldspar. Its coarse-grained texture means that the mineral grains are larger and more easily visible compared to diorite. Both diorite and granite are widely used in construction and quarrying industries. Due to their durability and aesthetic appeal, diorite, with its darker color and harder texture, is often used for building materials such as road bases, foundations, and monuments. Its resistance to weathering and erosion makes it suitable for both indoor and outdoor applications. Meanwhile, granite, with its light color and coarser texture, is commonly used for countertops, flooring, stairs, windowsills, and other decorative purposes. It is prized for its strength, durability, and natural beauty, making it a popular choice for both residential and commercial projects. Now let's talk about how these two rocks are formed and how that affects their properties. As we mentioned earlier, both diorite and granite are intrusive igneous rocks, meaning they cool and solidify below the Earth's surface. However, the magma from which they form has different compositions. Diorite is formed from magma that is rich in magnesium and calcium, but relatively low in silica. This type of magma is known as tholeiitic magma and is associated with mid-oceanic ridges and island arc magmatism. On the other hand, granite is formed from magma that is high in silica. This type of magma is called silicic magma and is commonly found in continental crust and as the source of rhyolitic volcanic eruptions. The process of magma cooling and crystallizing is complex and influenced by factors such as the rate of cooling, pressure, and the presence of other elements. For diorite, the slow cooling of tholeiitic magma allows for the formation of large crystals of minerals such as hornblende and plagioclase feldspar. The medium-grained texture of diorite is a result of this crystallization process. Similarly, granite forms when silicic magma cools slowly, allowing for the growth of large crystals of minerals like quartz, feldspar, and mica. The coarse-grained texture of granite is a reflection of this crystallization pattern. Another key difference between diorite and granite is their density. Diorite is a relatively dense rock with a specific gravity ranging from 2.65 to 2.95. This density is a result of its mineral composition, which includes heavy minerals like hornblende and biotite. In contrast, granite is a less dense rock with a specific gravity. Ranging from 2.45 to 2.75, the lower density is attributed to the lighter minerals present in granite, such as quartz and alkali feldspar. But here's where things get really interesting. The differences in their mineral composition and texture between diorite and granite have significant implications for understanding the deep interior of the Earth. You see, the Earth's mantle, the layer beneath the crust, is primarily composed of silicate minerals. However, at great depths, the intense heat and pressure cause these minerals to transform into denser forms. This process of metamorphism affects the mineral composition of the mantle, creating variations in its properties. Now, imagine a scenario where the Earth's crust and mantle have been physically swapped, much like the layers of an Oreo cookie. In this case, the Earth's outer layer would consist of the mantle with its denser minerals, while the inner part would be made of the crust, including the continental crust with its lighter minerals. If we were to drill a hole through the Earth and analyze the rock samples, we would find diorite in the outer layer and granite in the inner part, assuming of course that the Earth has not been turned inside out. This is because the minerals in diorite are more stable at the high pressures found in the Earth's mantle, whereas the minerals in granite are more stable in the lower pressure environment of the crust. This idea of the Earth being turned inside out is not as far-fetched as it may sound. In recent years, studies have provided evidence that parts of the Earth's mantle have indeed been found at the surface, particularly in areas where tectonic plates have collided. These occurrences of mantle material on the Earth's surface provide valuable insights into the Earth's deep interior. By examining these rocks, scientists can study the properties and behavior of the mantle without the need to drill deep into the Earth, which is currently not feasible due to technological limitations. It is quite remarkable that rocks like diorite and granite play a role in helping us understand the hidden layers of our planet. Their distinctive mineral compositions serve as clues to the Earth's internal structure and processes. Finally, let's talk about the uses of these two rocks. Both diorite and granite are highly valued rocks due to their durability, strength, and aesthetic appeal. They have numerous uses in construction, landscaping, and other industries. Diorite, with its darker color and harder texture, is often used for building materials such as road bases, foundations, and monuments. Its resistance to weathering and erosion makes it suitable for both indoor and outdoor applications. Additionally, diorite is used in the production of crushed stone and aggregates for concrete and asphalt. The aggregates from diorite are particularly useful in road construction due to their durability and ability to withstand heavy traffic. On the other hand, granite is widely used for countertops, flooring, stairs, windowsills, and other decorative purposes. Its light color and coarse-grained texture make it a popular choice for kitchens and bathrooms. Adding a touch of elegance and sophistication to interior design, granite is also used in the construction of monuments and sculptures due to its durability and ability to withstand the passage of time. Its natural beauty and resistance to weathering ensure that granite structures remain standing for centuries. So there you have it, folks. We've explored the fascinating world of diorite and granite, uncovering their unique properties, uses, and the clues they provide about the Earth's hidden layers. From their mineral composition and texture to their applications in construction and landscaping, these two rocks continue to captivate scientists and builders alike. Next time you come across a piece of diorite or granite, take a moment to appreciate the geological wonders that have created these marvels of nature. Thank you for joining me on this journey through the secrets of diorite and granite. If you enjoyed this episode, don't forget to give it a thumbs up. Subscribe to my channel for more exciting explorations of the natural world. As always, keep asking questions and exploring the world around you. Who knows what fascinating discoveries await you? Till next time, stay curious and keep learning.